Welcome to Train Signal. You're watching a lesson on IP addresses. Now, I'm sure you've heard that term IP address before. As a matter of fact, I'm pretty certain I've probably already used that term many times throughout this course. Well, in this lesson, we're going to go ahead and make sure that you fully understand exactly what an IP address is. So when we ask the question, what is an IP address? Well, the definition is that it is a 32-bit address. And before I go any further, why am I saying 32 bits? Because technically it's made up of four 8-bit, and this is of course talking in binary, 8-bit numbers. And you take 8 times 4 and you get 32, right? So it's a 32-bit address that is used to uniquely identify a computer on a network. I mean, that's all there is to it. It is an address that identifies a computer. And to be more specific, it uniquely identifies it. It makes it different than any other system. But let's talk about how the IP address is actually broken down. The reality is that an IP address is made up of two components. It's made up of a network ID and a host ID. Okay, so you're going to take this one step at a time. We're going to say we have this thing called an IP address, and one portion of it is network ID, and the other portion of it is host ID. Now, the network ID is responsible for identifying what network the computer is on. Okay, so it is just what it sounds like. And the host ID uniquely identifies the computer within that network. Okay, so the network ID puts it on a certain network. The host ID makes it unique within that network. Now, the big question that a lot of people ask here is, if we have an IP address like I have displayed on the screen, right? I have 192.168.10.1. If we got these four numbers and there's dots between them, well, how are we breaking this into two components? How are we making this a network ID and a host ID? Well, here's what we know. We know that the network ID is the left portion of the IP address, and the host ID is the right portion of the IP address. We know that, okay? That's by definition. Network ID is on the left, host is on the right. What we don't know is where to draw the dividing line, right? I mean, where do I put the line, right? We got these four numbers. How do I know what part's on the left and what part's on the right? And that's where we refer to something called the subnet mask, okay? And you typically will see a subnet mask with a bunch of 255s and zeros, although we'll see in an upcoming lesson how there can be other numbers besides 255 and 0. But the idea here is that if you had a subnet mask of 255.255.255.0, well, the 255s, those three of them, they represent the network ID portion of the IP address. Okay, so that means that in this example, 192.168.10 is the network ID. That's the name of the network that this particular computer would be on. And the 0 or zeros in a subnet mask will represent the host ID portion. So in this example, there's just 1 0, just representing the last number, which means the last number in the IP address, or the .1, is the host ID. Now, if we were to use a subnet mask of 255.255.0.0, you'll see here that the network ID becomes simply 192.168, and the host ID is 10.1. Or you move to 255.0.0.0, and only one number makes up the network ID, just 192. And then the last three numbers, 168.10.1, make up the host ID. And that's why you always have a subnet mask along with all IP addresses, because the IP address by itself cannot definitively say what network ID and what host ID are being used. Now, we'll learn later on in another lesson how we used to use something called class full IP addressing, where you can make certain assumptions about a subnet mask that should be in place even without seeing it. But the reality is that you can't always assume that we're working within the rules of class full IP addressing. But I don't want to get too far ahead of myself. For right now, I just want you to know that you have an IP address and a subnet mask, and the purpose is to break apart the left side, which is the network ID, and the right side, which is the host ID. Now, if we look at a simple network here, on this network I have the the internet, right? You got a cloud representing the internet, right? And then there's this firewall router, which is separating our internal simple network from the internet. And I will tell you that technically this firewall router has 2 IP addresses. I'm showing it as 1, and that's just the inside connection of this firewall router, whereas there would be another one connecting it to the internet. But again, that would be moving forward into another lesson. But we have a server on our network which has an IP address of 192.168.10.201 with a subnet mask of 255.255.255.0, which tells me that this server is on the 192.168.10 network, and the 201 is the unique ID on that network. Whereas if we were to look at the client, the IP address is 192.168.10.101 with the same subnet mask, telling me that, again, it's on the same network, 192.168.10, but its unique address on the network is 101. And if we take that a step further and look at the firewall router, you'll see that it has an IP address of 192.168.10.200 with the same subnet mask, putting it on the same network. In other words, all 3 of these have the same network ID, and it has a unique address of 200. I want you also to notice, even though we're not going to talk about it at this point, that there is, at the bottom, it says DG. That stands for Default Gateway for both our client and our server. And the IP address listed for that default gateway is the IP address of the router. I just want you to keep that in the back of your mind, and we're going to address that before the end of this lesson. So now that we know how exactly an IP address is formatted, let's talk just a little bit about planning an IP addressing scheme. There's a number of questions that you kind of need to ask yourself, or at least ask the environment that you're in. And some of those questions are, how many IP addresses do you need right now? Okay, right now, where we stand today, in the company that you're working for, in the company that you are putting this together for, how many people are there? How many computers are there? How many IP addresses do you need? But not only do you want to look at how many you need right now, you also want to know how many do you think you're going to need in the future. Now, this is an unknown, right? I mean, nobody can truly predict the future, but you should be able to analyze the type of growth that the company is going through and what kind of future, or at least we should say near future growth the company is going to go through, and make sure you plan for that as well. And then here's a big one. Are you dealing with a pre-existing IP scheme? In other words, is there a current network in place and maybe you've just joined onto the company and you've been given this task of putting together an IP addressing scheme? Or do you have this luxury of creating something from the beginning? Now, there's probably more questions than just these 3 that you're going to want to really look at when planning out IP addressing. But the main thing that I really want you to really pay attention to here is when you are planning this, the emphasis is looking at everything. Don't just go, well, let's see, right now, all right, we've got 50 computers, so we need to plan for 50 IP addresses. No, you really need to look at the whole everything. What do we have right now? Where are we going in the future? And what's every other aspect we can be thinking of that we're dealing with right now? So the next thing that I'd like to talk to you about is the rules of IP addressing. And these aren't all necessarily literal rules, but these are all, I don't know, we could say good tidbits of information you should know about IP addresses as a whole. Now the first thing is each of the 4 numbers in an IP address, right? There's 4 numbers when we say something like 192.168.10.1. Okay, that's the 4 numbers. Well, each of those numbers is actually called an octet. And the reason it's called an octet is because it's technically an 8-bit binary number. Now, when we say 8 bits, I will tell you that each bit is represented by a 1 or a 0. And again, these are just definitions of using binary numbers. And when we get to the binary math lesson, you'll see how this all comes together. And as a matter of fact, one more piece of information that you would get from that other lesson is knowing that each of those octets can only have a number from as little as 0 to as big as 255. That's all you get. 0 to 255. Okay, and the reason is because when you do the binary math, that's all you can have. Now here's the first, I don't know if you want to call it like a literal rule. And that is that the first octet, or for simplicity we could say the first number in an IP address, cannot be 127. The reason is because the entire range of IP addresses, so 127.anything.anything.anything, is reserved. Okay? When this was all created way back in the beginning, that range was reserved for diagnostic use only. Now, many people kind of find this interesting because of that entire range, and it's quite a large range, and we haven't gone into all the statistical numbers of how many IP addresses there are and this and that, but I can tell you that that range is almost 17 million IP addresses. They can't be used when the reality is there's one single IP address, which is 127.0.0.1. Just that one, which is primarily used, and that's referred to as the loopback IP address. Okay, so even though that's primarily the only one that's actively used, I mean, I'm sure there are others that are used in other high-level scenarios, but entire range of 16 million, or really it's almost 17 million. You'll see later it's like 16,777,216, if I have my math right. But anyway, just the one. Now let's get back to another rule. The host ID, okay, because remember, the IP address is divided between the host ID and the network ID. Well, the host ID portion cannot be all zeros, nor can it be all 255s. Now, an example of this is if you ever see the IP address 192.168.10.0, okay, and we're using a subnet mask of 255.255.255.0, and I apologize, again, there's extra pieces of information that are coming from other lessons if you're not familiar with all of this, that to really bring this all together. But the point behind that is if the network ID is 192.168.10, right, because of the 255s, then the 0, which is your host ID, well, that's not a valid IP address. What that technically is, that's known as the network ID, or the network representation for the 192.168.10 network. Okay, so I hope that wasn't confusing, because again, I know there's pieces that are going to come together in other lessons, but that's why you can't use all zeros, because that represents the network ID. Now, I also mentioned you can't have all 255s. And so the example would be 192.168.10.255, where the host ID is just simply 255. That, believe it or not, represents the broadcast address for the 192.168.10 network. Okay, so a broadcast, okay, which we talked about what a broadcast is in another lesson. This broadcast where you have one computer who is sending something out that is to be received by all other computers. The way those computers know that they're all supposed to receive it is because it would be sent with the all 255's host ID. That is how that is defined. Now, the next thing that I want to talk to you about is something called internetworking. Now, I don't want you to be confused with it sounds very similar to internet, right? Because we said internetworking. It's a generic term, internetworking, whereas an internet is a proper term. Internetworking is the idea of having systems that can communicate from one network to another. The idea is if you have computers like we had in our simple network, where they're all on the same network ID, then they can all communicate directly with one another. But if you have computers that are on different networks and therefore have a different network ID, well then they need to use a device called a router to be able to communicate from one network to the other. And on the screen, I've given you some examples. The top example is where we just have within our own, we'll say, local area network, although some people would argue by using a router it becomes a wide area network. That's kind of really super old school. I only mention it because, again, you might come across somebody who's been doing this for a long time, and if they bring that up, I don't want you to find yourself in an argument. But let's say in your own local area network, in your own office, you have more computers than you care to have on a single network. You want to have some kind of division. Well, you can divide them into different logical networks with the IP addresses, and then implement a router to make the physical connectivity to allow from one network ID, or I should say a computer that has one network ID, to a computer with another network ID. The second example I have is how you get from your office network to the internet, right? That's your own internal network connecting with the World Wide Web, the internet. You need a router. Third example I have there is from your home. And you'll notice I used a slightly different picture here. And by the way, speaking of pictures, I don't want you to picture what a router looks like because they come in all kinds of shapes and sizes. But the picture that I'm using there is one that looks similar to the type of cable modem DSL router type device that you would have to get from your home network to the internet. And the last example where routers are used might be from one office to another office, like a branch office or something like that. You'd actually have a router at each end, and the routers would then talk to each other. Here, I've actually put together an example where you can kind of bring this all together, right? In other words, you have your main office divided into many different networks. Some people call them different subnets. And we'll talk about subnetting in another lesson. And then we see how that office is connected to the internet. We see how it's potentially connected to a branch office. Notice the branch office is not only connected to the main office, but it also has a router connecting directly to the internet. Okay, so you have the two different paths. You have a branch office up top that can only get connected to the internet, and then you have your home network. Okay, this is a very common example that you'll find with many organizations. So the question you might be thinking to yourself right now, and there's a term that I already used once just a few minutes ago, and a lot of people do think about this, is, well, wait a minute, I thought in order to get from my computer out to the internet or to another network, I had to go to a default gateway, but you just finished telling me that it's a router. Well, let's talk about what exactly a default gateway is. The default gateway represents the IP address of a router that the computer will use to communicate outside its network. So the point is, a default gateway is a router. Okay? In other words, when you put a default gateway into your IP configuration, you're giving the IP address of the router that you're going to go to. Okay? That's really the only difference between a default gateway and a router. It's very subtle. So if we go back to our simple network, the default gateway is nothing more than an IP address which points you to the router. Okay? It's the IP address of the router. Now, the next thing we need to talk about when it comes to IP addresses is private versus public IP addressing. And this is something that is pretty important. Matter of fact, I think I've been saying that a lot. I think everything in here is extremely important. But the idea here is understanding that there are certain private IP ranges which have been reserved from public internet use. Okay, so these IP addresses are not valid on the public internet. You cannot travel the internet using these IP addresses. And the list of addresses I have here are 10.anything, meaning the entire 10 network. Okay, meaning that's using 10 as the network ID. And then the last 3 octets would be the host ID. 172.16.anything all the way through 172.31.anything. And again, 172.16, 172.17, 172.18, all the way to 172.31. Those are the network IDs going all the way through all the various host IDs that go with it. Those are all private. Now the next one is, and this one gets a little confusing for some people, is 192.168.anything. Now the reason I've highlighted 3 numbers instead of just 2 is because typically with 192.168, the network ID is going to be 3 octets. Okay, so it's going to be the first 3 numbers. So what we're saying is 192.168.0, 192.168.1, 192.168.2, all the way through to 192.168.255. And all of those are the network IDs, and then just the last number would be the host ID. And then finally, we have the 169.254 range, which is actually, this one's an extra special range, which we'll talk about in a minute, which is used for a PIPA, automatic private IP addressing. Okay, but we'll come back to that in just a minute as far as what exactly that means. But the point is that these addresses right here, they cannot be used on the internet. So one question that you might be asking yourself right now is you might be saying, hey Ed, wait a minute. You just gave me a list of IP addresses that are not valid on the internet. But I have one of those IP addresses on my computer right now, and I will tell you one of the most common addresses used would be 192.168. something, especially if you're at home with the typical home internet router. So you might be thinking to yourself, well, wait, I have one of these addresses, but yet I'm also on the internet. How is that happening? Well, I will tell you that that is done through a technology called Network Address Translation, or NAT. Okay, so now the idea behind Network Address Translation is, well, just to put it simple, we're taking private IP addresses and translating them to public and therefore valid on the internet IP addresses. Now, one other thing, just quick little side note here. Whenever you see NAT, sometimes you will also see something called PAT, P-A-T, which stands for Port Address Translation. And this is similar, but not really. The idea here with Port Address Translation is it has to do with if you have traffic coming into your network, just to give you an example, on a given port. Okay, so maybe you have traffic coming in which is designed for a certain service and therefore using a certain port, and you're going to then have a server set up to handle that traffic. Well, we may translate what address that traffic is heading toward based upon its port. So it's a similar concept. But for right now, I want you to stay focused on network address translation. I only wanted to mention it because it does sometimes come up in the same context, and I kind of really wish it wouldn't, because it's not completely the same. But as far as network address translation, let me see if I can't show you here exactly how it works. So here I have a diagram to try to help illustrate how NAT works. And the idea here is that I have this internal network, right? I have these 3 client computers that all have internal IP addressing, 192.168.10, and then they're .101, 102, and 103. On top of that, there's actually a 4th internal IP address, and that is the internal side of the box acting as the NAT server. Okay, the NAT server is going to act almost as a form of a router here, in the sense that it's going to have 2 network configurations. Right? It's going to have 2 network cards, one touching the inside network and one touching the internet. The one thing that is missing from this drawing is that these 3 clients would all have a default gateway of 192.168.10.200. In other words, pointing to the NAT server. The NAT server also has an external IP address, and that is not on the list of internal only ranges. Right? We have this external IP, which is totally valid out on the internet. The last thing in this picture that I just want to point out to you would be the web server down at the bottom, and we're going to see how that comes into play in just a moment. So let's break this down. We have a client on our internal network, and it wants to get out on the internet, right? It wants to make a request out to a web server, wants to go to a website. Well, what it does is it takes that request and it sends it over to the NAT server. The NAT server will then translate the source IP address from 192.168.10.101, which is where it actually came from, right? That's the client it came from. It will, well, before it even translates it, it stores that in its memory. Okay, it puts in its memory, hey, this client was looking for this website. Then it does this translation to the external IP address. In other words, it changes it and says, I'm going to say that the source address of this packet is 131.107.56.103. And then I'm going to send it out on the internet over to the web server that we were looking to connect with. Okay, and don't worry about the IP address of the web server. That's just random. It's some web server that's out there. And that web server only knows that it got that request from 131.107.56.103, something that is valid on the internet. It doesn't know at all about 192.168.10.101. What actually happens is the web server will get that request. It will then reply back to 131.107.56.103. The NAT server will receive that request. It will look into its memory and say, who was looking for this website? And it says, oh, client 1 was. And so it translates the destination IP back out to 192.168.10.101 and sends it on back to the client. That is how NAT works. And that is how it's possible that you can have an internal private IP address like 192.168.10. And I'll tell you what, many people in their home networks, because most typical internal home networks will have 192.168.1. That's probably the most commonly used network out there. But yet we're all getting on the internet. It's all done through network address translation. Now, the last thing that I want to talk to you about when it comes to all things IP addresses is the idea of how do computers, or really any network device, how do they get assigned these addresses? Right? Meaning if these addresses are identifying the network device, how do we actually assign it to them? Well, there's 3 main ways that this happens. The first way is something called statically. Or some people actually refer to this as manually. And the reason why is because if you're going to do static IP addressing, that means that every single computer on your network is going to have a predetermined IP address statically assigned to it. And the reason sometimes people refer to this as manually is because you, the administrator, are going to have to go to each one of those computers and configure that IP address manually. As you can probably guess, this is not very practical in most networks. Not only that, but you open yourself up to a lot of possibilities of making mistakes. Okay, you might think, oh wait, this one was supposed to have this IP address, but actually, no wait, I already gave that to somebody else. Okay, that happens all the time. The one place where statically assigned IP addresses do make sense is on your servers that are providing significant network services. You want those guys to be static. You don't want them to be a moving target. Okay, so that is one way that you can assign IP addresses. The next way would be with the use of a DHCP server. Now, there's a lot that I could tell you. Matter of fact, an entire lesson that we'll go through on the whole big picture of how DHCP works. But for right now, I want you to understand a real basic concept. A DHCP server is a box that has a pool of IP addresses. So an example I could give you is, let's say we have this box and it has a pool of 192.168.10.1 to 192.168.10.99. Okay, that's our pool. As computers come on, if they have been configured, and by the way, this is typically the default configuration, if they've been configured to automatically get their IP address, they'll go out to that DHCP server and they'll ask, hey, is there an available IP address for me? That server will look at its list and say, yeah, here's one. Here you go. Now, one thing that you should know is that not only is that DHCP server handing out those IP addresses, but it's actually maintaining that list of who has what. Okay, so you, the administrator, actually have the ability to look at the DHCP server to help troubleshoot sometime and see like who has this IP address versus this IP address. Now, there's a third way, and I will tell you, this third way is related to the second way. Really, there's 2 ways they can get an IP address, statically or dynamically. But this third way is something called automatic private IP addressing, or a PIPA. And where this comes into play is if you have a computer that has been determined to get its IP address automatically, but there's not a DHCP server available to give that IP address, then that computer will revert to a PIPA, and this is a process where the computer will say, all right, well, I can't get an IP address, but I'm supposed to get one automatically, so I'm going to automatically give myself an IP address in the 169.254 range. Okay, again, remember, there are certain ranges that are reserved for private use only, can't be used on the internet. This is one of them, but this one has a special purpose to where it's just for this. It's just for automatic private IP addressing. And the way it works is one computer comes on and it randomly gives himself this IP address, and then another computer comes on and randomly gives itself an IP address in that same range. Both of these computers have a 169.254 IP address with a 255.255.0.0 subnet mask. That means they're on the same network. It means they can talk to each other. But remember, it's private IP addressing, which means it cannot go to the internet. As a matter of fact, a default gateway is not even assigned as a part of a PIPA. What that means is these computers cannot get on the internet, but the good news is they can talk to each other. So this is pretty much how your computers can get their IP addresses. And remember, it's two main ways, either statically or dynamically. But you take that dynamically way and you kind of break that down into two subcomponents, the DHCP server or through a PIPA. And so that brings us to the end of this lesson. And at this point, you should now have a good firm grasp on what this thing is that we always refer to, this IP address. You hear that term all over the place? Well, it shouldn't just be a term to you anymore. Now you should understand exactly how it's broken down, why it's used, how it gets assigned, and all that good stuff. So that's all I have for you. I'll see you in the next lesson.